Hello everyone, welcome back to Kredict. Today is day 3 of 45-day challenge Learn Blockchain Development with Kredict. I hope you have joined me today for the third day of this challenge. So, without wasting any time, let's get started. First of all, I'm going to open my web browser. I'm using Chrome. You can open whatever you want. And in the previous sessions, we have seen how we can install MetaMask wallet, get test ETH, and set up our password. So let me quickly open my wallet and I can show you. So if you are following along, you know how to switch to Sepolia testnet and how to get these test ETH from the faucet. So if you don't know how to do this, please watch previous videos and then continue with this. And we have also seen what is Remix IDE and how does it looks like. So today we are going to work on Remix IDE and write some basic smart contracts. So if you remember, we have saved Remix ID in our bookmarks, or we can open with remix.ethereum.org. This is the official link for Remix ID. When you open this ID, make sure you are on the same URL. So let me quickly press enter. This is our Remix ID and we have already seen this thing. So this is contract. This is a basic storage contract that shows how to store any number in the smart contract and retrieve it. And these are other smart contracts like owner that shows the owner implementation of smart contracts. We will see this in upcoming sessions. And third is a ballot, which is for a voting smart contract that have some functions like delegate, vote, bidding proposals, and etc. So we are not going to work with this. We will create our own smart contract today. So close all these three. Here, I'm going to create a new folder. To create a new folder, you can right click a new folder, or if you want, you can click on this icon also. If we have worked on VS Studio, this looks like similar. So let me quickly make a new folder. I will name it as 45 or simply blockchain tut. So I've created my folder and now I'm going to create my new file here. I can name it as first contract. And here is the interesting part. The extension for Solidity file is .sol, S-O-L, .sol. You may know extensions for different languages and different types of files like .png for an image, .py for a Python file. Similarly, .sol is for Solidity files or the files in which we write smart contracts. So we have created our file here. Now first of all, if you remember, the line 1 says about the license. Specifying license is recommended but not mandatory always. For now, we are skipping that part. So our first line is to specifying the version we are going to use with the smart contract. And if we talk about versions of Solidity language, click on the Solidity compiler, drag it a little bit, and here click on this. You can see all the available versions for this compiler. It's starting from 0.1.1 to all the way 0.8.24. And yes, this is still updating and you will see upcoming versions in the future. Currently, while shooting this video, the latest version is 0.8.24, but we can use any of the version above 0.8. So let me quickly use 0.8.2. I've selected 0.8.20 for my compiler, and I have to specify this in my Solidity file. So let me show you how you can specify this. First of all, write pragma. Pragma is a keyword in Solidity that specify the language and version to the compiler. So we are going to use Solidity. I will type Solidity. And here we have to type the version. We can type versions in many ways, but the most used is 0.8.20. In this way, you specify this program requires version 0.8.2 at least and all the versions after this, which means it can run on 0.8.21, 0.8.22 and so on. So we have specified our Solidity version, and you can see this is a warning which says SPDX license identifier. This is all about license. We will see this in future. Okay, so we've specified our Solidity version or Solidity compiler version. Now we will start writing our smart contract. To start writing a smart contract, we have to define its body, and to define its body, we have to write contract. This is same like class in other object-oriented programming languages. So you can write here contract space name for our contract. So let me quickly type it first contract here. Yes, you can rename it as same as the name of file. There is no problem. So and put a curly braces. So this is a body of contract. You have to follow this structure or syntax when you are writing any contract in Solidity. So now we have created our contract body or the syntax for it, and you have to write all of your code related to this contract inside these curly brackets. Okay, so let me quickly start writing some code. So first of all, if you are familiar with other programming languages, you know every programming language has some data types. Solidity also has some of data types like integer, string, boolean, etc. We use uint in Solidity. Uint, you can say unsigned int. Unsigned int is integer values that cannot store negative values. Let me quickly show you. If you want to specify an integer that stores both positive and negative numbers, you write int the name of your variable. I'm going to write it here number and semicolon. Yes, Solidity has the concept of semicolon for line termination, and you must have to follow this like other languages in C, C++, Java and etc. We have declared our first variable of integer data type, and it has a name number. Integer data types are designed to store integer values from negative to positive, which means you can store both type of values, negative integers, positive integers, and 0 obviously. So if you write some example here, it's like -5, -100,000, 56, 9, 100, and all these integers are there. And if you don't know what is this is comment. Comments are used for putting nodes in our source code, and this has nothing to do with the execution or compilation of the code. So this is only for us. So we have seen integer data type, but what is uint or unsigned int in Solidity? Here uint, I'd say amount. So this uint is similar to integer in storing variables or values, but it cannot store values in negative. For example, you can store 56 here, 9 here, 100 here, but you cannot store -5, -1000. These values are not allowed. That's why it's called unsigned int, which means numbers does not have any sign in this data type. So why to use unsigned in Solidity? Because generally we deal in the number of balances, amounts in Solidity, like token balance, cryptocurrency balance, and you can think for it that balance does not go in negative, which means you may have $10, but you may not have, or even you might not have -$10. You may have $0, positive 0, but nothing in negative. That's why the uint data type is highly used in Solidity. You can of course use int, but this is not recommended for values which you don't require to go in negative. Okay, so let me quickly delete this, and now we are going to declare a variable or initialize it. So let me quickly type it here, uint balance n equal to 4500. So here we have declared our variable and initialized it with a value of 4500, or you can say 4500. We can store positive values, but we cannot store negative values. So here's the errors comes up. Is not implicitly converted to expected type uint 256. And what is this 256? Let me show you. We have uint data types of multiple range. We have uint 8, we have uint 128, uint 256. So we have these types of, and we also have other types. This is a 8-bit unsigned integer, this is a 128-bit unsigned integer, and this is 256-bit unsigned integer. And if you write just uint, it directly means you are writing uint 256, which means uint and uint 256 is exactly same. This is just a shorthand for writing unsigned int of 256-bit. You can use this if you know that your values are not exceeding a certain limit, or for safer side, just use uint. But deciding which type of unsigned integer you are going to use saves a lot of space in some conditions, because blockchain is executed by consuming gas fees. So if you want to reduce gas fees, you have to choose your data types very responsibly. Okay, so let us see the next data type in the list. Solidity also support string data types. You have to write string, you can say here name, and assign a value to it. I'm going to name it as John. So here we have two variables. One is balance of unsigned data type, and second is name of string data type. You can also have bool or boolean. It's like valid. You can specify true or false here. Yes. So these are data types supported in Solidity. And one thing I make you remember that Solidity does not have data types related to decimal places. Let me show you what I'm saying. In languages like C or Java, you have a data type called float, which stores values like 6.4, 9.10, or say something like values which have floating points. But in Solidity, there is no data type to storing float values. Yes, you cannot store float values or decimal point values directly in Solidity. We will see how to deal with this in future, but for now you have to keep this in mind that you cannot use float values directly in Solidity. Okay, so this is a basic example of data types and variables in Solidity. And in Solidity, or in the language of contracts, these are called state variables. We have seen here some data types in Solidity. And I think now we can move forward with a basic Solidity smart contract and deploy it. So let me quickly increase the font size that it is clearly visible to everyone. Okay, so I think now it is visible. And let me zoom the page also. Okay, so now I think now everything is visible. Okay, so let me quickly create this thing. Now we are going to write our first working smart contract and see how does this work and what does it do. For now, I'm going just to write simple smart contract that has a name. We can update the name and we can see the name. Or we can say we design a function that returns that particular name to us. And yeah, there is no function like print in Solidity because there is nothing like standard output in Solidity. It just returns the value and accepts the value, and all these things are worked by functions. So without wasting any time, just quickly write a smart contract for us. So let me create a variable of string type, string. I will name it as name and assign nothing to it for now. Now, I'm going to create a function for setting the value to this variable. And how to write functions in Solidity, just write function keyword space the name of function. So I'm going to name it as set name brackets. You can think is like code in JavaScript but with some changes, because Solidity is a JavaScript based language. You can think this code is like JavaScript because it's quite similar to the structure and syntax of JavaScript. So we have written set name, and now here we have to specify the scope level of this function. For now, I'm going to just write public. We will see types of specifier and what they exactly do in future sessions. For now, just write it here and put a curly braces, a opening and close curly braces, and press enter and goes inside this function. Now here our function is defined and we will write the code that we want to execute with this function. And here you can see the remix ID estimated the gas fees for this function. It's 122 gas. I will explain you all these things later. So let's quickly write our function. So if you want to update the name variable, we must have to get this value. So how you can get this value? We can get this value from function's parameters. Here we write our parameters we require when executing this function. So here I'm going to write string name, or you can say, for clear, it's new name. Okay, so now you can see here red lines comes up, which means there's something fishy or there's a problem in this statement. For now, just a quick thing, to store string data types or string type variables, we must have to specify where we are going to store this. We'll explain this later. For now, just write memory, which means I'm going to store this in memory temporarily. Okay, so now just write name equal to new name and semicolon. This is our function which sets the new name value to our variable name, and this is our set name function is completed. Now we are going to write a function that returns the name to us. Just quickly write function get name, and we don't have to pass anything to this because we are just accessing the data from smart contract, and we have to write it public. And now here's a different thing comes on. We require this function to return the name, so we have to specify which type of value we are expecting it to return. For this, just write returns and data type string. And yes, here you also have to specify memory. So now what we're going to do, we are just going to return the variable name. Let's type return name. And you can see there's a yellow lines comes up, which means this function does not change any state of blockchain. And this means, in simple words, this function is updating value, but this function is only retrieving and update nothing. So we can specify this function as view. This function just returns value and nothing can be changed, or this function does not change anything on the blockchain. So we can add a keyword here, says view, which means this is a only view function and it does not update anything on blockchain. And by using this, we can save a lot of gas fees. So here are the first smart contract is completed, which has a variable, a function to set our variable, and a function to get our variable's value. This is a simple smart contract you can write, and this should work fine. So let's see how you can quickly test this smart contract. For this, just open this Solidity compiler and make sure the compiler version is as per the specification. And you have to click on this button, compile first contract.sol. This is our function. This is our smart contract name. Just click on this and it will run, and here shows the error or warning. There's just a simple warning of SPDX license. We can ignore this, but there's no error. That means our smart contract is now ready to deploy. To deploy smart contract, click on this icon here, says deploy and run transactions. Now here are many things, but for now just focus on this Remix VM. This is a virtual machine by Remix where we can deploy our smart contracts. It provides us tens of wallet addresses with 100 Ether each, and these Ether are nothing to do with real money. They are all just for testing purposes. Yes, we can connect our MetaMask wallet, but we use it in upcoming sessions. For now, just stay with Remix VM. Account, just select the first account. Gas limit, you don't have to do anything with this for now. Skip this, and the contract. Here you have to select your contract. Currently we have opened only one contract, so it's showing only one. Just click on this, and now the deploy button. Just click on this, and here in console you can see a green tick. That means our contract is now deployed. And here below you can see deployed contracts. This is our contract. So congratulations, we have deployed our first contract. Just click on this icon, and here you can see our deployed contract. It has a set name function, a get name function, and you can see there's also field for set name, which requires a variable says new name. So this is like here you can see the set name function requires a parameter and get names require nothing. So we have not set any name and our variable is empty. So let's see what it returns. Click on this get name, and it returns string type of nothing. So it's blank, which means nothing. So let's type a name here. So I type the name and click on transact. You can see the green tick here, which means the function is executed successfully. And now if you click on get name, you should see the name we have passed here. So this is how the smart contract works. We have a function, we have another function. One function set the value and second function return the value. And if we want to re-update this, we can do this. This time I'm gonna write Travis John and transact, and again I'm going to click get name, and you can see the updated name here, Travis John. So this is the most basic example of a smart contract, how the smart contract structure looks like and how to deploy on a virtual machine provided by Remix. And the interesting part here, you can see the values is drops to 99.99 something, which means the deployment of smart contract costs some amount. Yes, if you want to deploy any smart contract on blockchain, you have to pay gas fees for it. We have nothing paid in actual because these all are for test purposes. So this is test ether, and we have deployed a test contract, and you can see here, and you can choose any of the address for different deployment of smart contracts and testing purposes. So this is how you can write a basic smart contract and deploy a basic smart contract. So for now, I'll show you one thing last. Smart contracts are immutable by default, which means you can change values in it, like we have changed the variable name, but you cannot change source code after the deployment. What this means, for now, if I change any of the source code here, this does not reflect in this deployed contract. If you want to get the updated thing, you have to redeploy this again, but the previous contract remains intact and has all the written smart contract previously in it. Because while deploying the smart contract, blockchain does not retain the source code, so there is no way to update existing source code. You can redeploy it, but you cannot change the previous one. So always keep this in mind. That's why blockchain is so secure, because no one can update the code. Let me quickly show you this, what I'm talking about. Let me quickly change this to a new function. I'm going to add a new function. It says update name public view. Okay, this is not a view, so we cannot write view here, and this does not return anything. So just quickly and provide a variable like string memory, another name, and set it to here like string name2, another name, and just quickly write a getter function for this function, get name2, so it's just return string, same, and this is returns, not return. Okay, for now I'm just going to close this. Okay, this is a return, and what should it return? It should return the name2. Okay, so we have created a smart contract, and we have now two variables of string data type, string name and string name2, and we have 4 functions in total, 2 for setting names and 2 for getting names. It's like set name for name1, get name for name1, update name for name2, and get name2 for name2. Obviously, yes, you can also name it as set name1 or set name2. Okay, so now it's clear for us. Now we have to deploy this to get all these changes. For this, open this Solidity compiler. You have to compile it first, or if you want the quick thing, you can enable auto compile here, and it will automatically compile the smart contract with every changes. So it's compiled now. Let's go to deploy and run transactions, and you can see there is no way to update this, so we have to redeploy. Okay, so I'm going to select this default address for now, our smart contract, and deploy. Here's green tick, which means the smart contract is deployed successfully. Now it scrolls down and you can see here's another smart contract comes up. Let's open this, and it has all the 4 functions. Let me quickly write names here. My name, set and get name, I can get my name, and here your name, set name2 and get name2, and your name. So you know how to update and execute these functions from this previous idea. So the point is, you cannot modify the source code of deployed contract. This is the point. I hope you get all these points, and if you have problems with this, don't worry. It's just an example of basic smart contract. In a quick way, we will see each step and everything in the smart contract later in the series. And if you have any doubt, just ask in comments. We will reply and try to solve your problem. So this is all for today. I hope you are going to attend this whole challenge and complete the blockchain development with us. For now, this is all from us. We will see you in next day or tomorrow. We will explore the further how to write smart contract. For now, stay safe. See you in next one.